Okay, good day, class. All right, so today we are going to continue. Okay, before this, we have learned how to use this Maclaurin's theorem. Maclaurin's theorem to find the Maclaurin series of any function. Use Maclaurin's theorem means, remember, you have to find your f0, f prime 0, f prime prime 0, and so on, and sub into the formula to get the Maclaurin series of any function. All right. Okay, so today we are going to continue with 5.1.2.2 series expansion of the composite function. All right, so at this part will be based on the standard Maclaurin series, the standard Maclaurin series that you have done before, and some is given in the formula list during the exam. All right, so now we are able to generate the Maclaurin series for the function, which are the composite of the common function. Okay, means that we are going to use the standard Maclaurin series. We just apply standard Maclaurin series to find the Maclaurin series for any function, any composite function. All right, means that we don't have to use Maclaurin's theorem in this part. Or also means that we don't have to find f0, f prime 0, f prime prime 0, and so on. We don't have to do that. We just use the standard Maclaurin series that we have, okay, to sub into the given composite function. From there, we expand and get the Maclaurin series for a composite function. All right. So later we'll discuss some examples, then you will know about it. Okay. And when we using standard Maclaurin series to find the Maclaurin series for the composite function, then we need to determine the new interval of the convergency of the series. Okay. So later we will also discuss this part. All right. Excuse me. So actually the question that using standard Maclaurin series to expand the composite function only so far only came out once in STPM 2017. This is until 2018 All right. So only one question at this part. Okay. So before we go to this past year question, all right, we will discuss exercise 5.2. All right, exercise 5.2 in the textbook, page 162, which is this part. All right. And exercise 5.2 also we have only 2 questions. All right, question 1 we have A until G, and then question 2. Okay, we are going to discuss a few questions in exercise 5.2. Okay, so you can refer to your textbook. All right. Okay, the first one. Okay, so this part actually before this the last video have done this part. Okay, you don't have to look at it. Okay, we will start from here. Okay, so exercise 5.2. So I'm going to discuss question 1A. All right, question 1A, you are actually asked you to, the question is, use a standard Maclaurin series to find the first 4 non-zero terms of the series expansion for the following functions. All right, then also state the interval of convergency in each case. All right, the request for first 4 non-zero terms. Okay, so the question actually want us to find the expansion for this function 1 over 4 plus x squared. All right, so from the standard series that we have, remember the standard series that we have learned. Okay, you can refer back to your textbook. Okay, you can refer back to your textbook, page 157. All right. Okay, these are what we call the standard or common Maclaurin series. All right, you can always refer back to this one. This is what we are going to use, okay, in this part. All right, so for this question, 1 over 4 plus x squared. All right, so when you look at this common series, so you have to decide which one you want to use. Definitely not ex, sin x, cos x, or ln, right? Definitely not this 4. Okay, this is binomial. Okay, the function that we are asking to calculate involve a fraction, so also not going to use this one, and of course not arctangent. So the only one standard Maclaurin series that we can use is this one. So we are going to use this standard Maclaurin series to find the expansion for this function. All right. So how we are going to do it? All right. So first we are going to choose, right? Yeah, we are going to choose which standard Maclaurin series that we are going to use. Okay, so for this question, we choose this standard Maclaurin series, which is 1 over 1 minus x equals to 1 plus x squared, and so on. All right, so we are going to use this. All right, now come to the function that we are going to find the expansion. This is a function. So means that we are going to rearrange this function into this form. All right, so if we want to express this into this form, the first term must be 1. This is 4. So definitely first step, we factorize out the 4. See? Okay, so when we factorize out the 4, so it becomes 1 plus x squared over 4 lah. Okay, so you see when you multiply the 4 inside, 4 times 1, 4. 4 multiply x squared over 4, x squared. See? Okay, so now it's in the form 1 plus something already. But this standard Maclaurin series is 1 minus x. But this is plus. So how to express in the minus form? Very simple. Okay, so you just write as 1 minus means, plus means minus minus, right? Yes. Okay. So the 4 here, I just write at 1 over 4 lah. The 1 over 4, I move it outside first. Easier to see. Then left, 1 over. 1 plus means 1 minus minus. Okay, x squared over 4. Just write in this form. Okay. Now, you see that this is this whole term. This whole thing. Alright? Can see. Sorry. I cannot see. Okay. Alright. Sorry. Okay. So, we repeat. 1 plus x squared over 4. So, we must write it in minus form, right? So, plus means negative, minus, minus. Alright? So, it become 1. The 1 over 4, we write it outside lah. Okay? So, left 1 over 1 minus negative bracket x squared over 4. Alright? Now it's in the form 1 minus x. So, this is your x. This is your x here. See? This whole thing is your x. Now, so, to use this standard Maclaurin series, very simple. Alright? You just sub all the x in this standard Maclaurin series become negative x squared over 4. Because it's 1 minus x, so this whole thing is your x. So all the x here, you sub by these terms only. Alright, just do like that. Okay, so next, you see. Okay, alright, so next, I'm going to sub into this standard Maclaurin series. So the 1 over 4, still 1 over 4 here. Okay, cannot see. Okay. The 1 over 4, still 1 over 4 here. So this is 1 over 1 minus x, right? 1 over 1 minus x. So the expansion, the series is 1 plus x squared. So 1 plus x squared plus x cubed, and so on. Right? This is the standard Maclaurin series for 1 over 1 minus x. Okay? And now, all the x, you are going to sub with this term. See? Sub with this term. Negative x squared over 4. Sub with this term. Alright? So, all the x become negative x squared over 4. Negative x squared over 4. Negative x squared over 4. Okay? Alright, now we are going to expand and simplify only lah. Alright, so 1 plus, so negative x squared over 4. So this, this is the whole thing square, you know. This whole thing square. So negative square become positive. So x square and square, x power 4. 4 square, 16. Alright, so the next term, negative cube. So still negative lah. Alright, x square to the power of 3, x power 6. 4 cube, 64. Okay, so the question 1, the first 4 non-zero terms. So 1, 2, 3, 4, enough lah. Others, we just use plus dot dot dot. Don't forget your plus dot 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 lah. Okay, now we multiply 1 over 4 in. Okay, we multiply 1 over 4 in. So 1 over 4 multiply 1, multiply in, multiply in, multiply in. All right, now you get this. So 1 over 4 plus x squared is equals to this. All right, so this is the expansion for this function by using this standard Maclaurin series. All right, this is what we mean, series expansion of composite function. So this is actually composite function of this thing. All right, okay. So remember, when we use the standard Maclaurin series to find the expansion of other function, so we have to find the new interval convergency. So we know that for this standard Maclaurin series, the x must be between -1 and 1. This x is for the standard one. All right, but our expansion here, for this function, now our x is this one. Okay, remember, Sasa, we sub negative x squared over 4 in. Yeah, so we want to find the interval for the x. So to differentiate, to make it different, looks different, so you can actually put a big X here, or capital X. Yeah, then you can see the difference. This is capital X, this is the X here. All right. Okay, so this is negative so we may multiply -1 to all the terms in this inequality. Multiply -1, multiply -1, multiply -1 become positive. So remember, when the inequalities multiply negative, the sign for the inequality have to change. All right, so we write it back into the proper form. Never mind. So the 4 can move to both sides, so become like this. Okay, then we write it in the proper way the proper direction of the inequalities. All right, so we have to solve this thing. So you know that to solve this inequality, I hope you still remember, we have to split into two. One is x squared bigger than -4. Another one is x squared less than -4. And the relation is n. Okay. All right. Then we know that x squared more than -4, but we know for all values of x squared is always positive, right? Therefore, the range to satisfy this part is all real number. Okay, and to solve this one, this part, shift the 4 here, factorize that. Okay, so the root is 2 and -2. We want negative part, so below the x-axis. So for this one, the range is x between -2 and 2. All right, so this is all real number. This is -2 and 2, and means intersect. So the intersection of this one and this one. Okay, so intersection means we take the smaller one. Therefore, this is the new interval of convergency for the expansion of this series. Okay, so for this, to find the value of this function by using this expansion, the value of x that we can use is between -2 to 2. Other than that, this function will be diverged. It won't be converged. Okay. All right, so this is what we mean. So after that, the following example also, we are going to do the same thing. We are going to do the same thing. Means first you choose which standard Maclaurin series that you want. All right, then next you have to express the function that you need to find the expansion into the form of the standard series that you already choose. Okay, then you have to determine what is the x that you are going to sub into your standard Maclaurin series like this. Okay, then you simplify them. All right. After that, find the interval of the convergency for the new function, by using all this method. All right. So it's just like this. So the following example, we are going to repeat the same thing. You will see that. Okay. So next question, we are going to discuss question 1C. All right. Okay, question 1C is arctangent x squared. Hold on, C. C. E to the power of -2x squared. Okay, so this is the second question. 1C. We want to find the expansion for this function, e to the power of -2x squared. All right, so as I said, first stage, we must choose the standard Maclaurin series that we can use. So definitely, we are using this standard Maclaurin series, right? Ex, which is equals to 1 plus x squared over 2 plus x cubed over 6 plus ... We want the first 4 non-zero terms. Okay, now, this is the new function that you want to find the expansion. Okay, so this one very simple. You know that your x here is actually same as negative 2x squared, right? So means that you're going to substitute negative 2x squared into all the x here. All right, so I write in bracket already, so we just substitute. So 1 plus x. So now your x is negative 2x squared. This one, half x squared, half x squared. So now your x is negative 2x squared, negative 2x squared. Right, the same step, right? Then simplify it. So 1 minus 2x squared. This one, negative square become positive 4. So 4 simplified with 2, so it's 2. X square and square again, x power 4. All right, negative cube, so it's still negative. All right, still negative. 2 cube is 8. So 8 multiplied 1 over 6 is 4 over 3. X square, then cube again, x power 6. All right, so you get the first 4 non-zero terms. So don't forget, again, repeat and repeat. Don't forget your plus dot, dot, dot. All right, this one. The interval of convergency for this standard Maclaurin series is Oreo number. So when the interval of the original standard Maclaurin series is Oreo number, then when you use this standard Maclaurin series to find other function, then the interval of the convergency also will be the same, Oreo number. All right, so this one we don't have to calculate again. Okay? All right. Okay. Next. So, question 1, I have discussed A and C. So other than that, you just do as homework lah. Okay? Okay, next, I'm going to discuss question 2. Okay? Question 2. So question 2, this is the series. This is a function, sorry. This is a function that we are going to find. We need to find the expansion. All right? So, like just now, if you compare to all the standard Maclaurin series, so you know that there is only one that we can use. Same like question 1a. You know that only this one we can use. Okay? But the problem is, this is 1 plus x, and then the whole thing cube. The standard one that we want to use is 1 minus x only. All right? So what we can do is, definitely, we want to write it in this way, right? This is only 1. So we have to expand this. Okay? By using the binomial theorem that you have learned. Okay? If you want to expand cube, so you have 4 terms. Remember? Cube, after you expand, you have 4 terms. And the coefficient is 1, 3, 3, 1. Remember? 1, 3, 3, 1. Okay? First term 1. So very simple. So the degree for the second term will be increasing, right? So start from 0, x power 0, 1, 2, 3. Very simple, right? So after we get this expansion, so we want to write it in this form. Okay? So this is the only thing we can do lah. So it become 1 over 1. This is plus, right? So become 1 minus negative this whole thing. So you see this whole thing in bracket. So now it is in the form 1 over 1 minus x. Alright, so now this whole big thing is actually our x. Alright, that we are going to sub into this standard Maclaurin series. Alright, okay, so this standard Maclaurin series is 1 plus x squared plus x cubed, right? Okay, so now this is your x, this is your x, and this is your x. Yeah, it's just a little bit complicated to expand it, all right? The first 2 terms, no problem, very simple. 1 plus, so this negative multiplied in each term. So it become 1, so minus 3x squared minus x cubed. These 3 terms. So here and here come to here already. This first, second term very simple lah. Here only. Okay, now we have to expand this one. All right, I think I show it here. Let me see. Here. I show it here to expand this one. You can see, Okay, I pull up a bit. Okay, To expand this second one, negative of this whole thing and square. Square means this one multiply this one, right? Square ma. Negative square positive already lo. Okay, so we expand this. So you see, first we use the, hold on, let me see. Yeah, okay. You see, we expand like this. Slowly. Okay, we expand like this. So first, we use the first term to multiply all these three, right? So 3x multiply 3x, 9x squared. All right? 3x multiply 3x cubed, so 9x cubed. Okay? And 3x multiply x cubed is 3x power 4. But remember, we want the first 4 non-zero term. So first 4 non-zero term means start with the constant x power 1, x squared, and x cubed only, right? Up to x cubed enough, because we only want the first 4 non-zero term. So this one multiplied this one is x power 4 already. So we can omit it. Okay, we can omit it. Alright, then next, use the second term to multiply all these three, right? So second term, multiply this one. So 9x squared times 3, 3x squared times 3x, so 9x cubed. 9x cubed, this one. Okay, and then 3x squared multiply 3x squared, again, already x power 4, which we don't need it. We can omit it. And x squared multiply x cubed, x power 5. We also can omit it. Alright? Okay, then suppose the last term also have to multiply this 3. Okay, so you see, the last term when you multiply this one already power 4, which we can omit. Power 5, omit. Power 6, omit. Alright, so the expansion for this whole thing, actually, we just need these 3 terms only. Okay, we just need these 3 terms only. Okay, alright. Okay, then the fourth one, cube. Alright, so we know that the first term, 3x, when you cube, you have 27x cubed. So other than that, you know that other than that will be the terms, okay, will be terms higher than power 3 already. You see, this one cube, cube means the square multiplied one more time, right? This is the square that we have already. Right? So the first term, when you multiply this one, is already 27x cubed. Others, no need to multiply anymore, because definitely it will be more than x cubed, that we don't need it. Alright? So even though this one look like very complicated, right? But don't worry, we just need one. But it's negative lah, because negative cube is still negative ma. Okay? Alright. So after simplified, so just left these terms only. Okay, now we group all the similar terms. Okay, we group all the similar terms. So only one constant, and only one x, just copy. Okay, so I have 2x squared here. 2x squared minus 3 plus 9. So plus 6x squared. X cubed we have 1, 2, 3, 4. Alright, so this one positive 18 here, plus 9 positive 18. So positive 18 minus 1, positive 17. Positive 17 minus 27, so negative 10x cubed. Alright, so we just need the first 4 non-zero terms. Okay? Alright, now the new interval. Yeah, it's a little bit complicated for the new interval. So start from here. So this is the original interval for 1 over 1 minus x. Alright? So now our x is this thing. So same, first step, we multiply negative to all the side. So the sign have to be changed. Okay? So to solve this one, we have to split it to this function less than 1, or this function more than negative 1, and also. Okay, so for this part, yeah, correct. for this part. All right, so -1 shift here, +1 here, okay, +1. All right, so when you can use a calculator, this one actually can be factorized, become 1 + 3 cube. Okay, so 1 + 3 cube positive, 1 + x cube, 1 + x cube positive, so 1 + x also must be positive lah. This one odd power, odd power. So doesn't mean that for all value of x always positive. No, that one is for even power. Okay, this is odd power. So if 1 + x cube positive, so 1 + x also must be positive. A positive number after cube, then only positive man. Therefore, x more than -1. Okay, so this is for this part. All right, then we solve this part. We solve this one, like this. So when your 1 shift to this side, -1. Okay, so this one, just like you see, we know that +1 can be factorized like this, right? So I also write -1 become like this. So I write -1 become +1 - 2. +1 - 2 means -1, and this part, just now we have done here, can be factorized. Okay, -2 negative, so 2 we shift here. So I have 1 + x cube less than 2. Okay, so 1 + x less than 2 power 1 cube root lah, or 1 power 3 cube root. Okay, so x will be less than cube root 2 - 1, or cube root 2 - 1. When you use your calculator, it's 0.2599. Okay, so remember, because this is cube, so we can do this. This is cube, we can do this. If square, then cannot. All right. Okay. All right. Therefore, you see this part x more than -1. This part x less than 0.299. All right. So when you use the number line, okay, when you use a number line means like this. Okay, this one less -1, this one 0.2599. Okay, this one more than -1, this one less than this one. So this is the intersection area. Therefore, the new interval for this question is x, it lies between -1 to 0.2599. Or when you refer to your textbook, they write 1 here, I think, which is not correct. Okay, it's supposed to have to solve like this. Okay, so this is question 2. Which is a little bit complicated lah. But if you really follow the step and expand it slowly, actually, not that difficult, but just a lot of calculation only. All right, so this is the example for question 2. All right. Okay, so now we will see the past year question. The only past year question here, 2019. Okay, in here I ask, can question for STPM 2013 repeat 2014 use this method, use this Maclaurin, standard Maclaurin series I show you the question. 2013 repeat paper is here. Here, this question. Use this one, ln 1 + sin x. Can we use this composite method? Actually can. Actually can. Or we can use this composite method. Means you use the standard Maclaurin series ln 1 + x. Then you sub in. Okay, actually can. But you see, in the actual exam paper, they say using Maclaurin's theorem. Because of this sentence, using Maclaurin's theorem. So you must use the method that find f0, f'0, f''0, and so on. To find the expansion series for this thing. You cannot use the standard Maclaurin's theorem. You cannot use the standard Maclaurin series like we have discussed just now. Okay, cannot, because the question wants you to use Maclaurin's theorem. Okay. If they never say using Maclaurin's theorem, then yes, you can use the method that we use just now. So I hope you understand this. That's why I always say, read the question carefully. Even though this question can be used, just now the standard Maclaurin series. Okay, but because the question say use Maclaurin's theorem, then we cannot. We have to use the concept f0, f'0, f''0, and so on. Okay, all right. Okay, this question, I think that day we didn't discuss. I wanted to do as homework, right? Doesn't matter. It's okay. Later. All right, so we will see one past year question, eh? All right. Using standard Maclaurin series. You see the sentence also different, right? Just now say use Maclaurin's theorem. Just now, the 2013 repeat paper say use Maclaurin's theorem. So you have to use the theorem. But you see this question, they say using the standard Maclaurin series. See that? Standard Maclaurin series. So means you don't have to use the theorem. You don't have to calculate F0, F prime 0, F prime prime 0. No, you cannot use that one. Okay? If you use that one, wrong method. Okay? So they want you to use this standard Maclaurin series. Find the series expansion for this function up to the terms in x cubed. They'll always tell you where you have to stop. Okay? Then deduce that the limit value of this one as x approaches 0. Okay, this is the second part. This one we will discuss after this. Okay, we will discuss after this. So today I only discuss up to here. Okay, so I will discuss this question again when we go to the behind part. All right, where we use Maclaurin series to find the limit. Then only I discuss. Okay, now we only discuss up to here only. Okay, all right, let's see. This is the question. Okay, so this is the question. They ask you to use this standard Maclaurin series, right? Sorry, cannot see. Okay, this one. All right. So they ask you to use this standard Maclaurin series, right? So you copy down the standard Maclaurin series. This is given in the formula list. Just copy. And again, as I told you, they will give you 1 mark here. All right? They will give you 1 mark here. And this is the interval of the convergency for this standard Maclaurin series. Okay, now we see this one. Of course, your standard one is ln 1 plus x, but this is a fraction, right? Okay, so remember, use a little bit the formula for ln. Ln 1 minus x divide 1 plus 2x is actually can be split like this. Ln 1 minus 3x minus ln 1 plus 2x. Ln divide can split as ln minus ln. We use a bit of this theorem that you have learned in Sem 1. Okay, so this is the part that you're going to use the standard Maclaurin series. Okay, so you see what we want is 1 plus x, but this is 1 minus 3x. Okay, so 1 minus 3x is actually like this. Can see 1 minus 3x you can write as 1 plus negative 3x. So now the x that you're going to substitute into the standard Maclaurin series is negative 3x. Alright, so all your x become negative 3x. So you see, I do it. Oh yeah, I do it here. See, I do it here. This expansion, this expansion I do it here. So ln 1 minus 3x is, I can write as ln 1 plus negative 3x. So you sub negative 3x into all the x in this standard Maclaurin series. Alright, so the question only want us to do up to x cubed only. So this x power 4 can forget it. Alright, then simplify them. Minus 3x, negative after square positive, so still negative. 9x squared over 2. Negative cube, still negative. Alright, so 27. 3 cube is 27. 27 over 3 is 9. So 9x cubed. Alright, so this is the expansion for the first one. And this one. Before this. So because this one we already used the standard Maclaurin series, right? So we have to find a new interval. Okay, so this is the capital X . And now your capital X is negative 3x, right? So same like what we have done just now. Multiply negative 1 to all the side. So you have to change the sign. Then the 3 shift. So you get this thing. So for this expansion, the valid value for x is negative 1/3 to 1/3. Okay? Alright, now next. This one. Ln 1 plus 2x. This one easier . This is ln 1 plus x. So means you're going to sub all the x become 2x. Sub all the x become 2x. All right. Then expand it, simplify that. 2 square is 4. 4 over 2 still 2 lah. 2 cube is 8. 8 over 3 lah. We only want the first 3 terms. So same like this one. Okay. So we find the new interval of convergency. So 2x lies between -1 and 1. So x lies between -half and half. One thing. Okay. This one, the interval of series include 1. So if we write in this form, it's like this. Got equal sign here. You see? Therefore, got equal sign here. Okay? Got equal sign here. This one, the equal sign is here. I forgot. The equal sign is here. Okay? Alright. So, I have calculated the expansion for ln 1 minus 3x and ln 1 plus 2x. Then, these two series, these two expansion, we sub back into the question. Okay? We sub back into the question. So, this first expansion minus the second expansion. When minus, so please remember your bracket lah. Then again simplify. So minus 3x minus 2x minus 5x. Minus 9 over 2x squared minus plus 2x squared. So negative 9 over 2x squared plus 2x squared, negative 5 over 2x squared. Okay? Negative 9x cubed minus 8 over 3x cubed. So it's negative 35 over 3x cubed and dot. Don't forget your dot or else you will lose 1 mark. Okay. Alright. So the interval for this whole thing. This is the interval for this one only. This is the interval for this one only. So the interval for the whole thing will be the combination of here and here. Not combination, sorry. It's the intersection. So this one is between negative 1/3 to 1/3 here. This one bigger, negative half and half here. Alright, so the intersection area is here. The smaller set. Okay, the smaller set. Therefore, the interval of this new expansion will be x between negative 1/3 less or equal, then less than 1/3. Okay? So for this question, we discuss up to this part only. The limit one, we discuss later. Okay? The limit one, we discuss later. Okay? Alright. So, now, what I need you to do is, okay, your homework. This one is homework lah. Okay? Homework, you complete exercise 5.2, the rest. Question 1, I have discussed A and C. So you have to complete B, D, E, F, G. Question 2 I have done. Okay? And also another one more question, which is STPM 2019 repeat paper. Alright? STPM 2019 repeat paper. Question 5. Question 5, you just need to do part A. Alright? Just need to do part A. So this is your homework. Okay? Now, you have another 20 minutes. Okay, you have another 20 minutes. So I want you to do this fast quiz. Okay, I want you to do this fast quiz, which is, sorry. Okay, sorry here. I want you to do this fast quiz. Yeah, here. Page 5. Your notes, page 5. I want you to do this question 4. Question 4, I want you to send me 2 solutions. 1, you follow the question. Using Maclaurin's theorem. Means you have to find the F0, F prime 0, F prime prime 0. Or use the actual way. Maclaurin's theorem. Find the expansion for this thing. Ln 1 plus sin x. Okay? Then you repeat the same question, but now you use this method. Okay? You use this method. Means you are going to use the standard Maclaurin series ln 1 plus x. The standard Maclaurin series ln 1 plus x to solve ln 1 plus sin x. Okay? Means you are going to sub sin x into here. See? you're going to sub sine x into this. And remember, sine x itself is another series, right? It's another standard Maclaurin series, right? Same. Okay, after you sub sine x into this standard Maclaurin series, okay, then inside the sine x, you substitute with the standard Maclaurin series of sine x. I hope you understand, okay? Like this. Okay, ln 1 plus sine x will be equals. So the first x becomes sine x. Okay, minus the second x squared means sine x squared over 2 and da 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 da. And then you sub sine x itself has a standard Maclaurin series, right? Yeah. Minus this standard Maclaurin series square over 2. Sub the standard Maclaurin series of sine x inside. Alright? Then you decide. You decide where to stop. When you expand, or you see, wow, so long, wow, I have to expand square and cube. Yes, just like the question 2 that we discussed just now, remember? This one? Yeah. Even though like a lot, but you just expand up to the terms that you want. Or not necessary to expand everything. Sorry. This question, what they want, let's see. They want, I'm to x cube only. Okay, so now, immediately, solve this question for me. First, using Maclaurin's theorem method. Second, use this standard Maclaurin series method. Alright, solve both. Okay, so in 20 minutes, after you have finished, upload it into your Google Drive. Okay, scan and upload your solution into the Google Drive. So means that by 9 o'clock, the latest, I give you 10 more minutes, by 9:10, alright, 9:10 a.m., you must forward your answer for this question into your Google Drive. Alright, okay, thank you class, see you next video.